Hello everyone. Today I will present our machine learning solution for predicting credit card approval decisions. Our objective is to develop a high-performing classification model that can assist financial institutions in evaluating credit card applications efficiently while ensuring transparency, fairness, and responsible use of artificial intelligence. In addition to building an accurate predictive model, this project focuses on applying responsible AI principles to ensure that the decision-making process remains interpretable and fair across different groups of applicants. During this presentation, I will briefly discuss the business problem, our modeling approach, the evaluation metrics, and finally, how responsible AI techniques such as fairness analysis and explainability help support responsible decision-making. The business problem addressed in this project in the credit card approval process. Financial institutions receive a large number of credit card applications every day. Evaluating these applications manually can be time-consuming and inconsistent. Machine learning models can help automate this process by predicting whether an applicant should be approved or rejected based on their financial and demographic information. However, automated decision systems must be carefully designed to avoid unintended bias and ensure fairness. Therefore, the goal is not only to maximize predictive performance, but also to ensure transparency and responsible use of AI in financial decision-making. To solve this problem, we first performed exploratory data analysis and data preparation. This included examining missing values, understanding feature distributions, and preparing the dataset for modeling. Categorical variables were encoded to allow them to be used in machine learning algorithms. The dataset was then split into training and testing sets to evaluate the model's generalization performance. We experimented with multiple classification models, including logistic regression, random forest, and gradient boosting models. After comparing the performance of these models, we selected the best performing model based on several evaluation metrics. Several evaluation metrics were used to assess the performance of the classifier. Accuracy measures of the overall correctness of the model. Precision measures how many predicted approvals are actually correct. Recall measures how well the model identifies true approvals. The F1 score provides a balanced measure of precision and recall. Finally, The AUC score evaluates the model's ability to distinguish between approved and rejected applications. These metrics provide a comprehensive view of model performance and ensure that the classifier performs reliably in the context of credit approval decisions. To ensure the model adheres to responsible AI principles, we implemented fairness evaluation during the modeling process. We examined approval rate across different demographic groups to detect potential bias. By comparing prediction outcomes across these groups, we were able to assess whether the model disproportionately favors or disadvantages any particular group. The results indicate that the model produced relatively consistent approval rate across groups, suggesting that there is no significant bias in the predictions. Conducting fairness analysis is critical in financial applications, as regulatory compliance and ethical considerations require decision systems to treat applicants fairly and transparently. To improve model interpretability, we applied SHAP explainability techniques. SHAP values provide insights into how each feature influences model predictions. Global explanations were generated using SHAP summary plots, which show the overall importance of different features in the model. Additionally, local explanations were generated using waterfall plots to illustrate how specific features contributed to the prediction for an individual applicant. This explainability techniques makes the model more transparent and allow decision makers to understand the reasoning behind automated credit approval decisions. From a business perspective, deploying this model can significantly improve operational efficiency. Automating the credit approval process can reduce manual workload, accelerate decision-making, and improve customer experience. At the same time, incorporating responsible AI practices helps financial institutions maintain regulatory compliance and build customer trust. By combining predictive performance with transparency and fairness, the model supports responsible adoption of machine learning in financial services. In conclusion, this project demonstrated how machine learning can support credit card approval decisions while maintaining responsible AI principles. By combining strong predictive performance with fairness evaluation and model explainability techniques, we developed a transparent and reliable classification system. These practices are essential for ensuring that AI systems in financial institutions remain trustworthy interpretable, and aligned with ethical and regulatory standards. Thank you for your time, and I look forward to your questions.